Welcome again for today's presentation on navigating the ever-changing energy code landscape in the 2021 IECC IRC edition. I think I mention this almost every time we do a webinar or in-person speaking engagement that our titles are always really, really long. Um, as is this entire presentation, so I won't belabor this very much, but I do want to give a little bit of a background and give some context as to, what drove me to develop this webinar in this format. As I mentioned, we do give speaking engagements, and this is a code change year here in Pennsylvania. So the staff here at the PHRC have been traveling all over Pennsylvania delivering code update classes, and one of those sections is the energy code update, which is rather small in comparison to the rest of it. But we talk about the updating of the R values and things of that nature. And then I've had follow-up conversations with folks like, well, Chris, you said that the new code R value, required R value, jumps up to R23, but I talked to my energy rater and he's like, we're good at whatever. And that kind of drove me to developing some content to put out there for the industry on the different compliance paths in the IRC and IECC, because they are not all the same. There are different compliance paths that we'll go through today, that can, if a builder or designer is looking for one application, there might be a compliance path that suits them better, and it might be a different compliance path than somebody else. So what we're going to go over here today in today's presentation on navigating the ever-changing energy code landscape in the 2021 IRC and IECC edition are the changes that are incorporated from going from 2018 to 2021, along with the amendments from the review that the RAC or the UCC Review and Advisory Council did on the energy codes, and how they are incorporated into the 2021 Pennsylvania UCC for compliance. Okay. So I, with all of that being said, that kind of goes over what the description and learning objectives are, that we are going to go through these different compliance paths. And, you know, I will jump back to this. I told the team that I'm not going to say that this is a very we'll call it a special session where it's not as spicy as what we've had in previous sessions where we have a lot of details and things of that nature. We're going to have a lot of code language in this. So I hope that doesn't deter you from having an amazing interaction with today's session, because this goes beyond today. I want this presentation to be a tool in your tool belt that whenever you're designing a home, you can look to this to find the best energy compliance path. If you are doing a code review on a home and you're unsure, they didn't choose or they didn't define which compliance path they're using, I hope that this is a tool that you can jump back to at some point in time and use the references that are here to help pull together a full picture of the compliance path that the builder's using. So again, this isn't something that is going to be I want this to be an evolving over the next 3 years tool for your tool belt, moving forward. And I did say over the next 3 years, and this is as I also said, a code change year. And some of the items that are going to jump out here today are going to be highlighting the changes going from what we're currently under, the 2018 I codes, that was pulled in through the UCC. And we're going to be transitioning from that and looking at language out of the 2021 I codes, both the IRC and the IECC. These are our Pennsylvania UCC Energy Code summary. These are the options available to us. We have Chapter 11 out of the IRC. We have the residential provisions out of Chapter 4 in the IECC. That combined with the RAC amendments give you a holistic approach on the energy codes through the I codes. We also have here in Pennsylvania an option called the Pennsylvania Alternative Residential Energy Provisions. I'll speak briefly on this at the end. This is a document that is published by the PHRC in conjunction with a subcommittee from our Industry Advisory Council that is a representative of many different industries within the state of Pennsylvania or the Commonwealth of Pennsylvania. That, along with public comment, pulled us together, and we have a formulated plan The modeling is complete. Now we're just pulling together the actual document, which will then be submitted to the Department of Labor and Industry mid-April and will be reviewed and ready for public use before the effective date of implementation of the 2021 codes, which is July 13th of 2025. I'm assuming at this point that a lot of this information is not new to probably most of you. I'm guessing that a lot of us already know that the code is changing legislatively every roughly 3 years. The Review and Advisor Council here in Pennsylvania review the latest triennial codes. We're actually one cycle behind what's published, and then every 3 years-ish, there is a new adoption process. And this one here for the 2021 I codes will go into effect on July 13th, 2025. So let's start at the beginning. I found it important to look at the very starting point in the IRC, and a lot of the main references that we're going to talk about here today come out of the IRC. However, as being shown in this section here, the scope N1101.1 states that this chapter regulates the energy efficiency for the design and construction of buildings regulated by this code. Again, this is the IRC, so this is encompassing of residential structures in Pennsylvania. But going into this note here, it does say, and this is just kind of a reference point, that the sections N1102, I'm sorry, N1101.2 through N1113 parallels that of the 2021 IECC. What that means is the language that we're going to talk about here today runs consistent in the IECC. A lot of the provisions that we're going to look at will have two numbers on them. It's going to be an N11 something, and then there's going to be another number that's 40 something. The N1101.1 here, this comes out of the IRC, and the numbers that are referencing 4, or in this case 1, are coming out of the IECC. The next thing here is above code programs. I'm sure most of us all know what an above code program. An example of an above code program would be Energy Star, right? But if someone declares that they are going to use Energy Star as their energy compliance path, that does not mean that they're allowed to do whatever they want as long as they pass that energy code standard, right? So in the IRC, section N1101.4 and our paralleled provision out of the IECC, I'm not going to name all of these numbers going through this, but would be R102.1.1 above code programs, says that the code official has the ability to deem a national or state above code program as its compliance path, but there are some backstops in the IRC that says that the requirements identified in table 1105.1, which is the requirements for total building performance, must also be met. So not only are you meeting the intent that's written in the Energy Star program, but you still have to meet the table, and I'm going to show what that looks like. And then you also have a backstop of efficiency and solar heat gain coefficients that jump back to the 2009 IECC in those tables. So really quick, I'm going to kind of jump outside of this and say that if you are interested in diving deeper into the backstops of the code, right? If there are, if that piques your interest and you want to learn more about that, I do want to call out that we will have a conference session. Register, housing conference, the 26th and 27th of this month. It'll be put on by Michael Arblaster from Harmony Home Energy and Michael Matthews from ResNet, and they're going to do an entire session on the backstops in the code. So that's kind of picking up where I'm just mentioning it and carrying it forward. And I would encourage you to attend our conference and jump in that session if you want to learn more about the backstops of navigating Pennsylvania's evolving energy code. But again, jumping back to this, above code programs still has written backstops within the IRC and IECC. This is the table that they're referring to, and you can see that there are a lot of mandatory items within this table. You see one crossed off here, and we'll get to that later on in today's presentation, but the energy efficiency additional energy efficiency package options do not need to be complied with. They were not adopted by the RAC. But you can look over here. You can see attic hatches and doors. You still have to comply with the installation of those items. You have to comply with mechanical ventilation. I'm not going to go through all of these, but just understand that just because they're choosing an above code program doesn't mean that they're fully outside of the scope of the IRC. Internal design conditions. This is written into the IRC at 75 degrees Fahrenheit for the minimum heating, and then the maximum, I'm sorry, the cooling load calculations shall be a maximum of 72 degrees, and then the heating shall be a minimum of 75 degrees. This is also very important to know because these design conditions or these interior design conditions aren't the same everywhere. If you look at some, again, above code programs, some additional programs that are out there, they do have different interior design conditions. So it's important to know, first and foremost, what's my energy compliance path? Right? If we find out that we are going within the IECC or the IRC, these are our interior design temperatures. This is important for many people to know. It's important for the builder to know and understand. It's important for our HVAC subcontractors to also know and understand what we're designing our interior design loads to. Moving quickly into applications, residential buildings shall comply with these sections. And this is kind of the meat and potatoes about what we're really going to go through today. So the one here listed at the top is additional energy efficiency. And you might be thinking, well, Chris, you just showed me a table that was crossed off. And that is correct. Jump into this next slide here. N1101.13.5 is additional energy efficiency. And this section was not adopted by the rack. Along with that, all references were also not adopted. So the rack report, section N1101.13.5, additional energy efficiency was not adopted as part of the current Pennsylvania adoption of the 2021 IRC and IECC. Along with that, removes all of the references. So if we jump to the scope and the actual section on additional efficiency package options, we are also removing the the reference of such N1101.13.5. It did not remove the provisions or these provisions for additional energy, or I'm sorry, additional efficiency package options. It just removed the reference. That might sound a little bit confusing, but this is why. N1108.2, additional efficiency package options, that section was left in the code. However, they did strike the mandatory requirement for use of this provision. This modified language leaves the provision in the code, but is no longer mandatory. They can now use these additional energy or additional efficiency package options as a guide for increased energy efficiency. However, they are not mandatory. So that leaves us really with three different options here. We have the prescriptive compliance path, and encompassing within that prescriptive compliance path, you'll find the R value alternative and the total UA alternative. We'll dive a little bit deeper into what they actually are here in a little bit. We'll also look at the next provision, which is the total building performance option. And then finally, we'll look at the energy rating index option, or ERI path. The last one here is not applicable to Pennsylvania as it is the tropical climate region option. We're just coming out of winter. It might feel tropical out there today compared to a month ago, but unfortunately, we're not the tropical climate region. Okay, so looking quickly here, this climate zone N1107, remember that reference or that provision N1107 is the climate zone provision, and this will carry through all of our different compliance path options. The climate zone map does carry through to all of those. But there is a change, right? So the climate zone map that you have currently in front of you is the 2018 climate zone map. More specifically, we'll zoom in here to Pennsylvania, and I'm sure we're all aware that we have three climate zones currently in Pennsylvania. We have the blue color here is representative of climate zone 6. The green color here is representative of climate zone 5, and the yellow color is a representation for climate zone 4. We are transitioning out of having 3 climate zones into the new 2021 climate zone map, which is now shown in front of you. I will zoom into Pennsylvania, but unfortunately, it's not as crisp and clear as the previous zoomed in version. But one thing that you can take note here is that we are transitioning from 3 climate zones in Pennsylvania to now 2 climate zones in Pennsylvania. There is now the removal of climate zone 6, so we only have climate zone 4 and 5. I do always say don't get too excited, because even though our climate zone 4 did grow a little bit, our climate zone 5 grew quite a bit. We're now covering roughly 2/3 of Pennsylvania in climate zone 5. However, when we look at the R value prescriptive requirements, the new climate zone 5 is more representative of the previous climate zone 6. Um, but again, we're going from 3 climate zones to 2 climate zones, and we'll look more specifically on what that means here in a little bit. All right, moving into the prescriptive compliance option. This can get, I don't want to say it gets overly confusing, but there are different compliance paths within this prescriptive compliance path option. Um, Looking at what we have available to us in the provisions that fall underneath the prescriptive compliance option, you have general, which we already went over, that kind of started off with the scope and moved through those items. And then we have the bulk of what's going to be talked about in the building, or I'm sorry, in the prescriptive compliance option, which is the building thermal envelope provision or section of this overarching section. What we're not going to get into here today is 1103, which is systems, and 1104, which is electrical power and lighting systems. If I got into all of that, we would not be here for an hour. We would be here for multiple hours. So to keep this manageable and provide context on true energy compliance paths, and an overview of them, we're going to strictly stick to the building thermal envelope portion of the prescriptive compliance option. And there it is, as being shown here, N1102, which also has some additional subsections, and we'll touch on some of these, some more than others. But the under N1102.1, which is the general provision out of the building thermal envelope section, it does say that the building thermal envelope shall comply with the requirements of N1102.1.1 through point 5. And those sections are being shown right here, with point 1 being vapor retarders, point 2 being the insulation and fenestration criteria. Point 3 is the R value alternative, which will ring bells once we get into that section. And then you have a smaller section, R value computation, which I'm going to ask a question. So be ready to answer a question in the chat pod, and that once we get to R value computation. And then N1102.1.5, which is the total UA alternative. Again, that is still a prescriptive pathway, but it is an alternative option within that pathway. This is an exception to the general statement the building thermal envelope must comply with, and it states that if you have a low energy building that meets the criteria of those peak energy usage, and those that do not contain conditioned space, along with log homes, you are exempt from those provisions. So as I had mentioned, the first one here is vapor retarders. Wall assemblies in the thermal envelope shall comply with the vapor retarder requirements of section R702.7. Now, for the sake of time, I am not going to dive into those new vapor retarder requirements. I did say new. There are some new provisions within that section. So if that is of interest to you, you can jump to, here's a shameless plug, and we're gonna have a couple of those, but a shameless plug to our YouTube channel. You can go to search at PHRC Penn State, or you can actually scan that QR code with your phone, and it'll take you to our YouTube channel, and then you can find the video 2021 PAUCC Residential Code Update Part 1. Jump to 38 minutes and 19 seconds, and that's where I start the vapor retarder discussion within that recorded webinar. Feel free to jump, not right now, after today's webinar. Be sure to like, subscribe, and hit the notifications. There it is. But anyway, if you want to find out more information on vapor retarders and what has changed in the 2021 provisions, I would highly encourage you either to reach out to us here at the PHRC. We're happy to answer that over the phone, or you can jump to that recorded webinar at 3819, and you'll be able to get that information. Jumping to the next provision under the prescriptive compliance option, it's N1102.1.2, the insulation and fenestration requirement. This really gives kind of an understanding or a pathway forward looking at U factors. And it says that the building thermal envelope shall meet the requirements of table N1102.1.2, which we'll look at. That's the maximum assembly U factor and fenestration requirement. And it must be based on the specific climate zones that you're in, okay? Assembly shall have a U factor equal to or less than those specified in that table. The fenestration shall have a U factor and glazed fenestration SHGC equivalent or less than to what's also specified in this table. So again, this is falling under the insulation and fenestration criteria. This is the building block, which then we can get our R value alternative from. If you'll notice, this table looks slightly different than what you might see in the written code book. I want to take a quick minute here to kind of address the fact that this has been modified. This table here does not come from the 2021 IRC or IECC. This table here actually comes from the RAC report, which you can find from the source linked right below this table. If you can, or if you want to download the handouts, they are available on our website, and all links should be active in that PDF handout. So again, you can download that, and this should be an active link for you. Jumping from the U factors, we jump right into the R value alternative. What the R value alternative is, me specifically, whenever I heard the words or heard the pathway of a prescriptive option, this is what my mind immediately jumped to, is the R value alternative. So this states that the assemblies with R value of insulation materials equal to or greater than specified in N1102.1.3, which is the insulation minimum R values and fenestration requirements by component table, shall be an alternative to the U factor table. Again, the code is specific and always having a starting point and then building from that. When we're talking about specific R values and U factors within the prescriptive requirements, our starting point is the U factor table, and then it builds from that. Right here is a great example explaining how this was the R value alternative is built from the U factor table. Again, same as the comments that I made on the U factor table, this also will not be found in your 2021 IRC or 2021 IECC, or if you didn't already know, you can actually view the codes online for free. So if you jumped onto, I believe it's codes.iccsafe.org, you can actually maneuver through their website and you can view the 2021 IRC and IECC online for free. However, you will not find this table. This is, again, modified and pulled in from the RAC report as sourced at the bottom of this page. Some things that I do want to point out, looking at climate zone 4, jumping across here, this looks very, very similar to what you've seen or you're familiar with previously in the current 2018 climate zone 4 with an R20 cavity only insulation. The other R values are very, very similar to both the current climate zone 4 and 5. However, I want to draw your attention to climate zone 5. Remember the map that we looked at earlier on? We had that small, roughly 1/3 of Pennsylvania fell within that climate zone 4. The remaining 2/3 of Pennsylvania falls within the climate zone 5. And then coming across, and I'm going to say prescriptively, the new requirement is an R23 cavity only, or R13 plus 7.5. So 13 would be cavity and 7.5 would be your continuous exterior insulation, or an option of R20 cavity only insulation plus a 3.8 R value of a 3.8 exterior continuous insulation. So this changes pretty dramatically from the prescriptive requirement coming out of the 2018. Now in climate zone 5 again, which is roughly two-thirds of Pennsylvania, you either have to have prescriptively again the R23 cavity only, or you have to have some sort of combination of cavity insulation with exterior continuous insulation. One additional thing that I'd like to point out is over here under your slab R value and depth is that in climate zone 5, you have R10 for 4 feet or R15 for 3 feet. This R10 for 4 feet is similar to the 2018 climate zone 6 requirement. Now that does encompass climate zone 5. Again, I sound like a broken record, but that's again roughly two-thirds of Pennsylvania in geographical area. I debated whether to put this in here or not, but I think it's really important to understand that there's a direct correlation between U factor and R value. Um, if, for instance, if you have if you're running the path of wanting to know what our average U factor is of our wall assembly, you can do that even though you only have the R value of the insulation. It's the inverse. So if, for instance, you wanted to know what the U factor is of R20 insulation, you do 1 divided by 20. That means like the results of that tells you that R20 insulation has a U factor of 0.05. On the adverse of that, if you wanted to know the R value of a window, but you only have the U factor, it's the inverse. So it would be 1 over 0.30. That spits out that your R value of a window that has a U factor of 0.30 is R 3.33. This is important to know if you ever wanted to do the U factor side of things and you wanted to get an average assembly U factor of your wall. You can take into account your R6.8 for your 2x6 stud. And if it's a framing factor of 25%, you know that 25% of that entire wall is going to be an R value of 6.8. You can get your square footage of your windows and apply your U factor of 0.30 to that if it's a 0.30 U factor window. And then you can convert your insulation. And in this case here, if it's an R20, you can convert that to roughly 75% minus your windows have a U factor of 0.05. So again, it's good to know the higher R value, the better it is, the lower the U factor, the better it is. So they are opposite of each other. Jumping into the R value computation, and this is where I'm going to ask the question. So looking at the very first portion that we have here, cavity insulation alone shall be used to determine the compliance with the cavity insulation R value requirements in table N1102.1.2, which is the maximum R value. I'm sorry, it's the minimum R value in fenestration requirements by component. So where cavity insulation is installed in multiple layers, the R value of the cavity insulation layers shall be summed to determine compliance with the cavity insulation R value requirements. So now that we just looked at our insulation and fenestration table and we found out that in climate zone 5, we have to have a total cavity only R value of R23. Can anybody put a scenario in the chat on where this would come into play, where we want to provide energy code compliance using the cavity only option, and we would take the sum of materials to show compliance? I'll take a second. There's lots of us logged in here today, so coming up with an answer should be, yeah, there it is, multiple coming in already. Thank you very much. Flash and bat, right? So if we needed an R23 cavity only, and we have the option here in N1102.1.4 to do an R value computation, we are able to add the insulation materials within the cavity to come up with a total sum R value. Flash and bat is exactly a perfect answer in this situation where you can have, let's say, 2 layers of closed cell foam, which is an R value of roughly 6 per inch. So 2 inches of that gives us an R12. And then you come in over top of that with a 3.5-inch fiberglass insulation of R13 that gives you a total R value cavity only for this assembly of R25. So absolutely, thank you all for playing along and putting in there Flash and Bat. Appreciate it. This also goes on to say that the continuous insulation alone, jumping outside of the cavity, right now we're looking at continuous insulation alone shall be used to determine compliance with continuous insulation R values. That means you cannot add your cavity only to your continuous insulation to get your summed requirement for continuous insulation, right? So you can only add up your specific either cavity only or all continuous. You can't combine those two to help achieve a higher R value for one of those two situations. The last pathway or option here under the prescriptive pathway is the total UA alternative. What this shows is, or what this goes on to state, is that where the total building thermal envelope UA, right, we're looking at the U factor, the sum of the U factor times the assembly area is less than or equal to the UA resulting from multiplying the U factors in our U factor table by the same assembly, right? So what we're talking about here is, remember earlier when I said you can convert your R value to U factors and you can look at what your assembly U factor is? You can do that for your total UA alternative, or you can actually use a program which we'll talk about here in a second. In addition to the total UA compliance, the SHGC requirements and the maximum fenestration U factors shall be met. Again, this is a small backstop stating that you cannot put one extremely high performing U factor material within that assembly and then allow all of the others to fall well below what the requirements are. That's, again, considered a backstop. An additional backstop in this, and hopefully, Mike, I'm not stealing the thunder from your conference session because I'm just scratching the surface of these backstops. It does state that the area weighted average maximum fenestration U factor permitted using trade-offs is 0.48 U factor in climate zones 4 and 5. Again, what this is stating is you cannot install an R30 wall assembly and then go with a 0.50 or 55 U factor windows. Doing those trade-offs, it's unacceptable. You have to still meet at least a minimum of a 0.48 U factor in climate zones 4 and 5 for your fenestration. So as I said, you can use alternative total UA calculators for this. One of those calculators is ResCheck. This is an example of an output stating that in this case here, it says it's compliance. It passes using the UA trade-off. And this is a trade-off. It can be a trade-off situation. One example that I'd love to give here, and how this can be considered or used as a trade-off is, are there any builders using either on the call or those that are doing inspections or reviews that are using R19 cavity only insulation in areas that need an R20 cavity insulation? More oftentimes than not, they're probably using the total UA alternative trade-off to allow that R19 to be compliant, where you might be dropped slightly in your cavity only R value. Remember, you need an R20, but an R19 is not R20. They're making up for that, or they're trading off for that in other areas. So maybe they're putting in a better performing window or better performing doors, whatever the case may be. They're making up for that slight reduction from an R20 to an R19 somewhere else in this total alternative calculation. So this again is being shown as compliant and it passes the total UA trade-off. It meets by 17.8% better than code, and it says that the maximum the maximum U factor is a 545, and that's the code minimum home, and then this home tested out at a 448, therefore it passes. All right, jumping into the total building performance, right? So we talked about the prescriptive option, right? That is kind of a cookbook option where you go in and you follow the instructions, and at the end of that, you can show energy code compliance. Even through the total UA alternative pathway, there's a lot of calculations that can be done there. It's still designed to be able to do that without having a calculator or like res check, right? Although res check makes it easier, you still can do it without it. Jumping into total building performance, this is where it kind of jumps outside of that box a little bit. This you oftentimes need to have an additional program that can help do what you're looking for it to do. N1101.13.2, which is the total building performance option, says that you have to comply with N1105, which is total building performance. This section establishes criteria for compliance using the building performance analysis. Such analysis shall include heating, cooling, mechanical ventilation, and service hot water heating only. Again, remember what I mentioned earlier, looking at the total UA alternative, we could include more efficient windows to make up for the reduction in wall insulation going from 20 to 19, right? That's a material trade-off, that's a value trade-off. What the total building performance now allows is looking at things beyond the building thermal envelope. Now we're looking at things within that structure that uses electricity, and now we're looking at taking those types of items into analysis. The compliance is based on the compliance based on building total building performance requires that a proposed design meet all of the following. The first one here is the requirements of the sections indicated within the table N1105.2. And you might be thinking to yourself, this looks awful familiar, and that's because it is. We did look at this earlier on when we talked about above code programs, and how above code programs not only had to meet their criteria, they also had to meet these items here. And I talked about the attic hatch and doors have to meet their certain insulation requirements, and we also have to meet, for instance, N1103.6, which is also R403.6 out of the IECC, for mechanical ventilation. They're just two examples that I talked about. You also have to look at the backstop here, and that's that building thermal envelopes shall be greater than or equal to levels of efficiency in solar heat gain from these such tables in the 2009 IECC. And that is what this looks like. So again, taking into consideration that you are allowed trade-offs, that does not mean that you can go with, in, for example, climate zone 5, an R21 ceiling insulation, right? We have our minimums of what we can roll back to meet compliance, and that minimum backstop is the 2009 IECC for total building performance. Not only does it have to meet these two items, which is the table and then the backstop, but you also have to meet the annual energy cost that is less than or equal to the annual energy cost of the standard reference design. I'm sure you can already imagine that there's going to be a software program out there that's going to do this for us. And with those compliance software programs, you're going to have a report, and those compliance software tools shall generate a report that documents the proposed design complies with N1105.2. But if you haven't noticed already, I tend to highlight in red some very, very important text when referring to code references. And just like all the other ones, here's this one that says a compliance report on the proposed design shall be submitted with the application for the building permit. That means that we can't choose our energy compliance path when we're insulating the structure. That means that we can't choose our energy compliance path at the end when we're like, now which one's the easiest one to comply with? What this does mean is we have to choose our energy compliance path up front, and we have to submit that documentation with the permit at the very beginning of this process. Upon completion of the building, a confirmed compliance report based on the confirmed conditions of the building shall be submitted to the code official before the CO is issued. So two things here. Number one, if we're going the total building performance path, if this is our energy compliance path that we're deeming up front, we have to supply with the submission of our permit our compliance path option as shown here. But it doesn't end there. We now have to have someone come back in and confirm that the compliance report is indeed accurate and it matches the on-site built product matches that initial compliance report. That all has to be done prior to the CO being issued. I don't necessarily know if I hear this always being the case. It's sometimes like, yeah, this is what they're going to go with. Up front, it looks great, and then at the end, there's no backside that is always consistent. I'm not saying it doesn't happen because I know it does happen, but sometimes it might be a question that has to come up. Okay, this is an example of the report. This can come from two different programs that can be used. Remember earlier on the res check when doing the total UA, that's simply a calculator. That is running the numbers on our exterior envelope and the R values and U factors and coming up with a conclusion. This program here is much more than a calculator. This goes beyond and actually does a simulated performance, and it takes a look at the anticipated energy usage of the reference home, which is the same parameters as the designed home, but it's installed or it's designed with code minimum requirements. And then looking at the as designed, all the inputs are then added in there. As you can see here across the top, it does take into account heating, cooling, hot water, mechanical ventilation, key mechanical ventilation. And then it does also state the anticipated annual energy usage for those homes. But again, not only is that all that you have to pass, these items down here under requirements, these might look familiar. These are all the items that are coming from our required table, right? So not only do you have to meet the upfront annual anticipated energy cost, but you also have to meet the additional mandatory features. And you can see here that some of these were not met. Therefore, ultimately at the end, this does not pass. Even though our performance passed, there are other checkboxes that are not checked. They have angry, triangle, exclamation points, which means you don't pass. The last one that I'm going to talk about here today, out of the IECC and IRC path, is the Energy Rating Index option or the ERI path. The ERI path, again, the title of this comes out of the initial general section, pointing to the specific section of N1106, which is the ERI compliance alternative. This section establishes the criteria for compliance using the ERI analysis. Again, analysis kind of leads you to understanding that it has to be done through some sort of a compliance software tool and cannot be done standalone. The compliance of the ERI requires that the rated design meet all of the following. The requirements as indicated in N1106.2, and I'm sure you're all thinking, boy, we've seen this table enough. But you have another table, N1106.5. Again, we have backstops here. You can have some trade-off options. You can design this home where maybe you aren't quite meeting all of the design criteria needed, but you do have to meet these ones. This table is very similar and comes up in all of these energy compliance options. These provisions here were pulled from the 2021 IRC, and as you can see across the top, they are struck as they were not adopted per the RAC report. So N1106.3, building thermal envelope provision under the ERI path alternative has not been adopted. Okay, so therefore N1106.3.1 or .2 has also not been adopted. And 1106.3.1 on-site renewables are not included. This was not adopted per the RAC report. So if you have your IRC book in handy, take your big red Sharpie and cross off N1106.3.1 as it was not adopted during the 2021 review through the RAC. And 1106.3.2 on-site renewables are included, has also not been adopted per the RAC report. We can cross that one off as well. Looking at N1106.4 energy rating index, the 2021 language was not adopted. What's being shown here is the language that was adopted. The way that it works is if the RAC does not adopt a provision, it rolls back to the previously adopted provision if there was one. Okay. In this case here, N1106.4, the energy rating index, there was a provision to roll back to, and that language comes out of the 2018, and it says that the energy rating index, or the ERI, shall be numerical integer value based on a linear scale constructed that an ERI reference design has an index of 100, right? That's a 2006 built home, and a home that uses no net purchased energy has an index of 0. So if it's a net zero energy home, it has an ERI, or energy rating index, of 0. If it's a 2006 code built home, it has a value of 100. And then that shows you your value scale in between. These are our maximum energy rating index. This was modified table from the 2015 review. We had to roll back many times to get this accurate table. This table has not been modified since. So if something is not adopted, it rolls back to the last adopted table, and that is this table that says that in climate zones 4 and 5, you have to have a maximum ERI of 62 in climate zone 4 and a 61 in climate zone 5. Again, finding or tracking down some of this information as it rolls back is not always the easiest. So this is, to our knowledge, the most accurate table showing what has or is going to be adopted once we get to the 2021. And I believe these are the same, or they should be the exact same energy rating index numbers that are currently being enforced for compliance. One last thing that I'm going to touch on here for the mandatory requirements for the ERI path. Again, this was not adopted or does not come out of the 2021 IECC. This comes out of the 2015 IECC. And this states that this is the ending portion of a provision, and it says that the building thermal envelope shall be greater than or equal to levels of efficiency and solar heat gain from tables 40211 and 40213 of the 2009 IECC. Again, this isn't the first time we've seen this table. If you've been paying attention and playing along here today, you're seeing a trend that a lot of these backstops for the insulation and fenestration actually roll back to the 2009. So the 2009 insulation and fenestration table is our backstop in a lot of these. And this provision here, again, this is coming from the 2018 language, as the 2021 N110641 was not adopted, and it states that exactly what I said earlier when talking about the integers going from 1 to 100, and it says the reference design shall be configured such that it meets the minimum requirements of the 2006 IECC prescriptive requirements, right? So that's the minimum. That's our 100 on our ERI scale, our energy rating index scale. 100, a score of 100 equals a 2006 IECC prescriptive designed home. All right, I'm not going to spend a lot of time here on the blower door testing, but again, this jumps outside of our above code program prescriptive total building performance ERI path. This is our blower door testing requirements, and the reason why I wanted to bring this in to today's presentation is because there is a distinct difference in testing when looking at a performance-based or total building performance compliance path versus a prescriptive performance path. And the new language here says that the maximum air leakage rate for any building or dwelling in any compliance path shall not exceed 5 ACH 50, or the new language here of a 0.28 cubic feet per minute per square foot of dwelling unit enclosure area. Dwelling unit enclosure area is a new defined term in the 2021, and that states that the dwelling unit enclosure area is the sum of the area of ceilings, floors, and walls separating a dwelling unit's condition space from the exterior or from adjacent conditioned or unconditioned spaces. Um, there's a whole lot to unpack in that little segment there, but it's all encompassing when talking about single family attached. When you're talking about separating conditioned space from adjacent conditioned space, single family attached, a townhouse, when you have conditioned space, right? We're talking about that same thing. That would be considered dwelling unit enclosure area, as well as single family detached when you're looking at exterior walls, concrete or basement floors, and your ceilings of your uppermost floor. Moving on, looking at the prescriptive side of things, we have N1102.4.1.3, which is air leakage, and it says where complying with N1101.13.1, which is the prescriptive compliance option. So when you're complying with the prescriptive compliance option, the building or dwelling unit shall have an air leakage rate of not less than 5 in climate zones 0, 1, and 2, but 3 air changes per hour in 3 through 8. So if you're someone on this call today and you're like, oh, right, we get to go up to 5 now. I'm sorry to burst your bubble, but if you are following a prescriptive compliance path, you're still reverting back to 3 ACH 50 for climate zones 3 through 8. Okay. So what does that mean, really quick? If you are a performance path for any climate zones, right? We are falling under the total building performance, and we are going to use Ecotrope or ResNet to show our energy code compliance. You can actually trade out from a 3 ACH 50 to a 5 ACH 50 and not exceed 0.28 CFM per square foot. Or if you have an attached unit or you're a smaller unit, 1,500 square feet or smaller, you can actually jump up to a 0.30 CFM per square foot of dwelling unit enclosure area. Now, if you're following the prescriptive path, so you're doing your R value alternative, or you're doing a total UA alternative that is falling under the realm of res check, right? You can then use or you have to jump down to not exceeding 3 ACH 50 because there's no trade-off, right? And you have the exception for attached homes and units under 1,500 square feet. That is an exception that follows suit for a 0.30. But again, this is another reason why it's very, very important to identify and solidify your energy code compliance up front, because it impacts everything from that moment moving forward. The last thing I'm going to talk about here quick in the remaining overtime already is the 2025 Pennsylvania Alternative Residential Energy Provisions. This is a compliance option developed by the PHRC in conjunction with a subcommittee with lots of oversight and input from the public comments. And it's allowed in Chapter 3 of the UCC. I'm not going to get into any specifics because we're still working through it. And it also comes out of Chapter 403 out of the Uniform Construction Code that says, right there at the very end, one of the compliance paths that's allowed is the Pennsylvania Alternative Residential Energy Provisions. This up here that says that everything below has to comply with the IECC that will be updated once the new code language is going into effect on July 13th. Some considerations that are taken into account for the Pennsylvania alternative is that it is, ultimately simpler to build, easier to enforce. That's subjective, kind of, more rational and flexible, which is also subjective. Focused in PA in terms of climatic conditions, which is true. And then the final thing here, to me, again, is one of the most important, is at the very end of the day, this is all modeled, and our requirement is that it must be equivalent. Whenever you choose your one entrance requirement, which increases the efficiency of the unit, you can choose all of the trade-offs, and at the end of the day, it must at least be equivalent to the UCC, or what's been adopted through the 2021 IRC or IECC. So ultimately, you choose one energy enhancement option that improves energy efficiency of the dwelling unit. And once you have that, it increases efficiency of the overall unit. You can then take all of the trade-offs, and when you incorporate all of those trade-offs, this scale never outbalances the entrance requirement. Therefore, it's assured to be at least equivalent to the prescribed code. This is the summary, and then we can wrap this up. The different compliance path options that we have the prescriptive, which you as I had mentioned is the R value alternative and the total UA alternative. They are defined as prescriptive. There's a second one, total UA alternative. Again, this is you can calculate it manually. However, ResCheck is probably one of the softwares out there that can better suit and crunch those numbers a little bit easier. You also have the simulated performance alternative. You have REM rate, ecotrope. That's the total, as indicated in the code, as the total building performance option. And then finally here, again, this is the IECC compliance path options in Pennsylvania. You have the ERI path as indicated in the code as the energy rating index. They are not indexes, not spelled correctly there, but I'm sure you all get the point.